Hello, it's me, Miss Wesley, and I have a question for you. What do you call a man who spends all day doing his trig homework on the beach? Well, if he did that, he would turn into a tangent. A tangent. We get to talk a little bit more trig today, starting with quadrantal angles found on page 6 of the Trig Packet, and I want to check out this warm-up with you. I feel like the setup of this is a little different from the previous find the 6 trig functions questions that we've already tried together. In general, you start, in my problems at least, you started with a set of coordinates, right? An ordered pair like 2, 3 or -5, 7. We've drawn out an angle to kind of envision a right triangle, or sometimes it wasn't a right triangle, but at least we had an X and a Y. Well, here we're going to do that for ourselves. You can draw a 90-degree angle, right? 90-degree angle takes you right up to the positive part, I'll just call that theta, to the positive part of the X or of the Y axis. And we're going to pick a point, any old point on this line. Any point would do. So really 0, anything positive could be the coordinates of this sample point. 0, 7, 0, 5, 0, 11 would all fall above the origin on that quadrant line. Let me just stay low and local and just keep it at 0, 1. 0 for my sample X value, 1 for my sample Y value that would be on the terminal side of this right angle. Well, we can use the relationship r squared equals x squared plus y squared. And you get r squared equals, what does it equal? 0 squared plus 1 squared. R squared is 1. And keeping r positive, let's use an r value of 1. Now we'll go in. I think we've got what we need, right? We've been using the definition sine is y over r, so 1 over 1. The cosine is x over r. So what is the cosine? Cosine is 0 over 1, so 0. And the tangent, y over x, so 1 over 0. Here's one example, and I know we've seen a few so far. We get a trig function that's undefined. All right, and then moving to the reciprocal trig functions, the reciprocal of sine is going to be your cosecant. We can flip the sign, and if I flip 1, I still get 1 back. So cosecant of theta also equals 1. What is the secant of theta? Well, flipping this into 1 over 0 will give me that undefined situation. And cotangent is last but not least. We can flip 0 over 1 and get a real number of 0. So lots of 1s, 0s, undefines, even negative ones are going to pop up for what are called the trig functions of quadrantal angles. I want to define them here, try another example, and see if we can come to a shortcut on finding trig functions of quadrantals. Quadrantal angles in standard position have their terminal side along one of the coordinate axes, the x or the y axis. So certain degree measures on these axes should come to mind, like 0 degrees, 90 degrees up here, 180, 270 down at the bottom, and then anything coterminal to those angles, like a 360-degree angle, 450, and so on and so on. So they get to be called quadrantal. Did we need to pick the point 0, 1? I was saying in the warm-up we could have picked 0, 7 or 0, 11. Would this point, because one of the coordinates is 0, fall along a quadrant line? Well, sure, the whole process should work regardless of what this value is for x. Well, -3, 0 is important, right? Because you know it's going to fall right along the negative x-axis. And the angle is quadrantal, right? Here theta would equal 180 degrees in standard position. Now, we have our x and y, so this one's already kind of marked out for us, and they want us to use -3 for the x. If you tried x squared plus y squared equals r squared, you get r squared equals x squared plus 0, right? Plus y squared is 0, you get r, that's also 3. Well, watch these final answers, by no coincidence at all, come out to be a series of 1s and 0s and -1s and undefines. Let me actually just get 3 of the 6 trig functions. I'm going to go with the sine of, I'll put 180 here. You could put theta or 180. Cosine, I'll put a 180. You remember the trig function, the notation here is that the angle, either a theta or an angle measure or something, always has to go after the trig function. So tangent of 180. And the sine is your what? The y over r. 0 over, well, it doesn't matter what non-zero numbers on the bottom, right? The sine of 180 is the value 0. The cosine of 180 degrees is x over r, so -3, but over 3 brings you back to a -1. And is there a tangent? Let's see. Y over r 0 over 3, you get a 0. And we could find the reciprocals too if we needed to. So let's get to that shortcut. So unit circle, one of my favorite things. We're going to flesh this out, get much more into this beautiful, famous unit circle over the next few lessons. And I will try to adequately show you my love for the unit circle. But let's just talk about it for starters in terms of quadrantal angles. Why is the unit circle called that? The unit circle. What about it is 1 unit? Well, to get from the center, 0, out to any point on that circle, you'd be traveling a radius of 1 unit. So it is the circle where no matter where you are around the entire thing, the radius is always going to be 1. And what that does is it should really simplify the definitions of the 6 trig functions, because anytime you see an r, you're going to be thinking of just putting in a 1. Here's what I mean. This is the equation of the unit circle. Let theta be an angle in standard position. What do we know the sine equals? The sine always equals y over r, but here, this is the unit circle, so r is just 1. So on the unit circle, the sine actually just equals y, and the cosecant is going to be its reciprocal, 1 over y. The cosine of theta, if you're dealing with a circle where r is always 1, is going to be x over r, but x over 1. The cosine is actually just the x-coordinate, and the secant is its reciprocal, 1 over x. So I'll pause there before I get to tangent. Here's what I mean. What if I said, quick, so-and-so, tell me the sine of 180 degrees? Well, if I have a little unit circle where you see the coordinates of these points are labeled 1, 0, 0, 1, -1, 0, 0, -1, I can go to 180 degrees, look at the 2 coordinates, and I can say, I know the sine of 180. It's the y, it's 0. It's still y over r, it's still 0 over 1, but there's no need to include that over 1 when you're dealing with unit circles. So the sine is 0. The cosine of 180 is -1. Is that what we got right above it? Yeah, cosine of 180 is always -1. Quick, what's the cosecant of 270? Go to 270 degrees, that's going to be down here. I asked for the cosecant. We're going to flip. Here's the x and the y. The sine is the y, right? Flip the y. Cosecant is going to be -1, the reciprocal of -1. Once I know the sine and cosine, it's always pretty easy to get the tangent. The tangent still, the definition doesn't change. It's still y over x. So the tangent's going to be the y coordinate over the x coordinate. And cotangent is its reciprocal still. So let me pick another one. What's the tangent of 90 degrees? I'm going to go to 90 degrees. I'm going to put the y over the x. So 1 over 0 in those coordinates, and you get undefined. Can we summarize this in a table here? I think this will be a good page. Page 6 will be a good page to look back to when we need to figure out facts about quadrantal angles. And let's go through the table, maybe angle by angle. So 0 degrees, if I want the sine of 0, right, it's going to be the y value at 0, it will be 0. The sine at 90 is 1. I'm always picking the y coordinate. The sine at 180 is 0, and then the sine at 270 is that y coordinate, -1. Just kind of like going through, filling in the blanks, always looking back at this diagram. How about the cosine of each? Cosine, I'm going to just list all the 4 x values. So 1, right, x value of 0 when you're up at 90, x value of -1, and x value of 0. You see these zeros and ones and -1s cycle through. The tangent, actually what's kind of crazy is, once I have these 2 columns listed, that should unlock the entire rest of the table for me. I know that the tangent is the y over the x. It's the sine over the cosine. It's this number over that one. 0 over 1 gives me 0. If I divide this by that, I have a problem. I'm dividing by 0, so I'm undefined. If I divide this sine by that cosine, I get 0 over -1 is a 0 again. And then here, this over this gives me another undefined. I'm just showing you it's pretty quick to run through the trig functions of these quadrantal angles on the table. Cosecant should come from the reciprocal of each of these answers. So I'm going to kind of use the top row for cosecant. Flip 0, you got undefined. Flip 1, you still have 1 back. Flip 0, you have undefined. And flip -1, reciprocal of -1 gives you -1 back. Can the cosine row help us with the secant row, all the reciprocals? So reciprocal of 1, reciprocal of 0, reciprocal of -1, I'm using the cosine, and then reciprocal of 0. And cotangent, you know what? I'm going to keep going with this reciprocal idea. I'm going to flip these things here, and when we get to the undefines, we'll just have to think a little harder about that. So reciprocal of 0 brings 0 to the bottom, you are undefined. For cotangent of 90, right, you're flipping undefined. Really, you're putting, cotangent is always x over y, if that helps. So you're putting the cosine over the sine. 0 over 1 brings you back to 0 for that answer. What about cotangent? X over y. So negative 1 over 0 is undefined. And last but not least, cotangent of 270. X over y, 0 over negative 1 gives you 0. So kind of nice table there. And what do you see on page 7? Tons of examples. Over the next couple of lessons, we're going to practice with what are called exact values. I do not want you to reach to a calculator for these. Resist the temptation. Instead, when you see a whole page like this, at the top, do this. Just sketch yourself a little rough unit circle here. And can you label the coordinates? If this is a circle that has a radius of 1 unit, can you label the coordinates at all the quadrantals? So at 0, the coordinates here would be 1, 0. I'm kind of just listing from memory what I saw on the last page on that unit circle. How about up here, right? At this point on that circle, you're up at 0, 1. At 180 on this circle, you're at negative 1, 0. And then here's 270. You could say 0, negative 1 would do the trick. And then let's try our hand at some of these exact values. Sine of 90, let the fun begin. Go up to 90, right? Sine is the y, and you don't have to think y over r is just 1. So sine is going to be that y coordinate. It's just going to be 1. It's second nature, right? We'll get more used to it the more we practice. Let's try sine of 270. Go down to 270, pick the y, negative 1. Cosine of negative 180, does that matter too much? I mean, whether you're going to 180 this way or that way, you're still landing at those two coordinates, and cosine is the x. Let's use negative 1 for that one. You want to try, see some negative angles and a pretty big one of 540 and number 6. You want to try 5, 6, and 7. Pause the video, turn it back on, check with me, see if we get the same thing. Cosine of negative 90, that's like saying 270. You're going to go down, cosine is going to be the x value, and I'll say 0. So it's just like saying cosine of 270, which is also known as 0. Okay, tangent of 540. Once I get an angle this big, it would be good to find something coterminal that's a little bit more manageable. So let's subtract 360 once, and you're going to get 180 degrees. You get the same exact thing. Tangent is y over x. So go to 180, we'll put 0 over negative 1. And tangent is 0. Tangent of negative 270, what's coterminal with that? If you're going 270 degrees in the clockwise direction, that's the same thing as just going 90 degrees counterclockwise. So if I added 360 to negative 270, I get the coterminal angle of 90 degrees. And tangent of 90, go up to 90, put the y over the x, and that is not defined. Okay. Next row, we're just taking these row by row. See if you could try 7 through 10, and then actually 7 through 11. Try those on your own, tune back in. Cosecant of 90 degrees. That's like saying 1 over the sine of 90 degrees. I'm going to go to 90 and flip the y value. So go up to 90, the y value is 1, reciprocal of 1 is going to be 1. Secant of 270, we need to flip the cosine of 270. If I can remember, so I don't have to keep flipping back up, down at 270, the x value is going to be 0 there, and that's what really matters. In this case, we'll say for that one, 0, negative 1 are your coordinates at 270, but flipping 0 is not going to fly. We'll go undefined for that one. Cotangent of 90, right? Cotangent, always going to be the x over the y, and here up at 90 degrees, 0, 1. Is this defined? X over y is going to give you 0. Cotangent of 720, no big deal that that's so big. You can subtract 360 once or twice. It's the same thing as the cotangent of 0, right? And at 0 degrees, you're at, what, 1, 0? Put the x over the y, and again, we get an undefined case. And you'll see we're going to work in some examples where you have multiple trig functions in one example. I know I'm kind of flying through these, but we'll have some time to practice and take our time with it. How about we incorporate 180 twice, right? Sine of 180. So negative 1, 0 are good coordinates to use. Sine is the y, so sine of 180, minus tangent of 180. Well, tangent of 180 is the y over the x. So we've just got 0 minus 0. Is nothing. Great. Stay tuned for the next one. Have a great day. Keep on practicing. I miss you.